Thank you so much. Really appreciate it, Brian. So thank you for attending my talk. We're going to be talking about building your front end with intention, just some architectural decisions and tooling, that you can use for your next front end project. I'm Chad Stewart. I've been a front end engineer for about 10 years now. Worked in enterprise, worked on open source, worked in smaller organizations, worked all over the place. So, yeah. I'm also the founder of Tech is Hiring. I also have the little label at the bottom that I'm pointing to that is completely invisible to me because I can't see myself now. But if you see a goofy person always asking somebody to retweet their job postings and stuff like that, that goofy person is me. So we just try to promote jobs and job seekers and information to assist job seekers. So you can check us out on Twitter and on or Twitter, X, Y, Z, algebra. and, and yeah, you can just check us out there for us promoting jobs and job seekers. Yeah, so front end complexity is sneaky. It's really easy to have like things like components that are being coupled, and it's really quick for components to it becomes a nightmare to build upon what you have. Like I have a good story. Actually, for a previous project, we it was a completely greenfield project, and everything was great. We're developers, we love greenfield projects, so I'm sitting there dancing in my chair. And it took we were working at it for the first couple of weeks. It was perfectly fine to update, add new features and stuff like that. It took about 2 months. Within 2 months, it came to a point where things just kind of grinded to a halt, and it was just very difficult to add new features, to the point where I was looking like this. I'm sorry. I've been practicing this. Every time I see this cat, it's so mad. I'm sorry. So what options do we have to deal with? You're going to see me giggling a lot throughout this presentation. So what options do we have to deal with front end complexity? So primarily, we want to encourage loosely coupled code, through components, through our business logic, which we'll talk about later. And it just allows us to kind of focus specifically on the use case for like the components that we're leveraging, where we're building. And yeah, it just makes it easier for people, for us and others to engage with our code base. So here are some of the things that we're going to talk about. We're going to talk about component-driven design, atomic design, functional / atomic CSS, separating presentation logic and business logic. I mentioned that earlier. Then some of the tooling that we're going to talk about is Storybook and good old TypeScript. So component-driven design. So component-driven design is pretty much the idea of thinking about our front-end application as a series of components, as opposed to we have this tendency of building things top down. You open up, you start like with a page, you build the layout, and then you build the components in a particular section. Component-driven design kind of challenges us to think of to build the components first, right? So I'll give a quick example. This is google.com. Probably could have found a better way to express this, but we just think about it as a single page, right? So we want to build the home page. We're like, okay, we'll just lay out everything we want. We're not even thinking about the components yet. Okay, now we build the components. We maybe build the header and so on and so forth. And component-driven design has challenges us again to think about the individual components first, and specifically to build them first. So we have these could particularly, like, I'm pointing at the screen as if you can see it. We have things like the Gmail images. Those could be text or images, ironically. We have icons, and then we have the Google logo, and we have the search bar, which I didn't differentiate too much, but you have the icon on the left and then two icons on the right that could be buttons, and then more traditional buttons at the bottom. But the whole point is to think about the components individually and build them out individually and then put them onto the screen. Atomic design is if component-driven design is more about thinking about our pages or or what we have on screen as components. Atomic design is a battle-tested way of putting relationships to those components, right? So if you've heard of atomic design was coined by Brad Frost in 2012 or 2013, I believe. I had an amazing talk. I highly suggest you go and watch it. It was a great talk. And the whole idea is to think of components as atoms, molecules, organisms, templates, and pages. So atoms, here we'll talk about atoms, molecules, and organisms first. Atoms are your building blocks. The way I think about them is that they rely on nothing else, right? So in this example, you have like your header, you have standard text, strong text, and then like you have an image here and things like that. Molecules are pretty much collections of atoms. So here you would have something like a card where you have a title in the card and then the standard text in the card and then a background or something. And the idea is just like a collection of a collection of the building blocks. And then organisms, the way I think of them is a collection of both atoms and molecules. And so we can take this process. We can take this component and we can add, say, for instance, an image here, which would be an atom, and these in collection would make an organism. I want to make a quick point here. So we have a button here. I'm actually going to show an example in code what these are, but button, like, these relationships are important to be consistent, but you can think of certain things, you can add certain things to certain relationships if you'd like to. So for instance, I think of buttons as an atom. I think of it as like the a fundamental component, whereas in this example, a button is a molecule. And I just want, it's about the relationships and being consistent with them. So templates are where you start putting your layouts in. The way I tend to use them is you define, like, you have layouts that you want to use throughout your site, and it's just a way of doing that. And also it's really important that, well, not really important, but you have them, it doesn't have any data. And the only difference between templates and pages is pages are effectively layouts with relevant data for the page. And yeah, that's pretty much it. So you have like these things, you have atoms that build molecules, that build organisms, that build templates, that build pages. And this is some code. This is actually from the Tech is Hiring website. That's an open source project just for the website. It's a little bit complicated looking. This is actually an atom. So it's an atom using Chakra UI, which is a UI library, very famous UI library. You can go look into that. The point I want to kind of point out here is that this button, outside of relying on Chakra UI, doesn't really rely on anything else within the project. And it's fairly simple, relatively simple. It's fairly simple. But yeah, it's just, this is like one of the bare bones components. And then we have a molecule. I want to point your attention to here. Notice that we're importing an atom and it leverages the atom. Obviously, you can have more than one, but the relationship that I want to point out here is that it's leveraging an atom, right? And it's like you can have an atom or multiple atoms. Technically, this is an atom as well. Probably need to change that, but this is an atom. You could, from the chart that we saw before, you could view this as standard text. But yeah, that's pretty much it. And then we have an organism. Again, I want to point out here, you look at the import statements, we have an atom and a molecule, and that's how you build this component out. So I just threw a whole bunch of words at you, right? Like, so why in the heck does any of this matter, right? Like, but why though? So I think the reason why this is important, like, is, well, I don't want to say the reason why it's important, but I had such a great experience building with Atomic Design. Actually, a couple of projects back, I ended up having to build an onboarding flow twice, right? And the first time I built the onboarding flow, took a couple of weeks. There was a lot of back and forth. It took a couple of weeks, sorry, a couple of days, and it was a lot of back and forth. And it was, yeah, it was a lot of back and forth. And then I ended up having to build another onboarding flow for a similar project. So I'm sitting there thinking, okay, I've done this before. It's probably going to take some time. So you know uh I'm just kind of prepared for that, right? So Friday afternoon, I sit down and I get to work, right? So you enter the flow state as you are as a developer. You're just sitting there, you kind of banging away at this, and then all of a sudden, 4 hours fly past, right? 4 hours fly past, and all of a sudden the component is more or less done. So I say it takes 6 hours. I sat there for like maybe 4 hours, and the component was finished. And then an hour of kind of going back, making sure that you're doing you've actually done everything properly. So 5-6 hours. But the whole point is, I've done this before. It took significantly longer, and I sat down there and I was literally flabbergasted at how fast it was to turn something over. So why was development like this so easy? And I think it's because, first of all, to be 100% fair, the project was a bit mature. It was a couple of weeks in. And so we had these components. We had a lot of the atoms and molecules built out. But I think the main thing is that leveraging atomic design is very much like putting Legos in the right place. And so you spend a lot less time actually having to build out the components over and over again, which tend to happen. I mean, like you're using a framework, you try to build things that are reusable, but that tends to it's a hit or miss on whether that happens. This just helps to enforce like the reusability of components. And so it's just very much taking the thing that you need, putting it where you need to do, maybe making a few edits here or there, and it makes the process so much easier. It removes a lot of the roadblocks. Like, so you rely on the idea that the component works, and if the component is in your code base and it hasn't messed up before, you have a lot of confidence in that you can just leverage it and edit it whenever you need to. And this wasn't even an isolated incident. So, as we're moving through the project, we ended up having a lot on our plate, and so we needed to pull more people in. Oh, we need to pull a freelancer in, sorry, to help with the project. And generally, this is a managerial no. If you bring somebody new, like the idea is, you have more than one person to help you with development. And generally, what ends up happening is you have to train the person, and the time that you would have saved, that you think you would have saved, bringing that person on, you spend having to train the person on the code base. And obviously the added cost of bringing that person on. That did not happen in this case. What ended up happening is that the person came in and they were able to contribute fairly quickly, like within days. They were able to contribute fairly quickly to the code base. And in my opinion, the reason why that is because when you have your components isolated like this, one of the big things that you don't have to worry about is you don't have to worry about learning the entirety of the code base or knowing all the intricate relationships with the code base. You can just associate with you can just think about the things that you need to work on, right? And so it allows you to consume the code base as somebody learning it very piecemeal. Right? So I do want to point this out. It's very something that I really stress. Atomic design is about the relationships between your components, right? And so atomic design is like, the analogy is based off of chemistry. And to be 100% fair, we don't necessarily have that type of thinking in web development at all. So, you have to train the person on kind of that thinking, right? So the point I'm making is, if you don't necessarily want to leverage atomic design, you don't believe in those relationships, an alternative is to build your own relationships, to make your own relationships between the different components. It's extremely important that you're consistent and you have a way of sharing this with the rest of your team. But the point here is having those relationships and leveraging them properly. So I just wanted to point that alternative out. So functional atomic CSS, right? So it's the idea of taking, instead of having CSS that is owned by a component, you make a selector, and then the selector, and then you have styles that effectively the component owns because of the way you've written the CSS, you've written the CSS, writing the CS. Again, I'm gonna be giggling through this entire presentation. But yeah, so instead of that, you have a suite of CSS rules. And those suite of CSS rules tend to be very small, in like a single type of action, and you apply those to your components. And the point is, it switches the ownership, right? Nothing owns the CSS now. You apply the CSS, you apply the CSS action that you want to your components, right? And so here's an example of traditional CSS. Again, in the way I was describing is effectively this. I am again pointing at the screen as you can see it, but again, you have this nav bar, obviously name menu, and then you have CSS that effectively the nav bar owns by being named the same way. Whereas functional CSS, this example is through Tailwind. I'm pretty sure a lot of people kind of have been have heard of Tailwind. It's a CSS library that it calls itself utility first CSS. And it's the idea here is, again, you apply a CSS class, you apply a class that has specific rules, and the idea is to apply effectively this styling, which is seen as an action to your components, right? The example here that I want to point out is, I want all the text in this component to be blue, and 600 is just how Tailwind has decided to do the shade of blue. Again, just said a whole bunch of things to you, So why does any of this matter? But why that? Okay, I'm going to entertain myself through the entirety of this presentation. So again, going back to Tech is Hiring, we have an open source project, Tech is Hiring, and a while back we had a major release, and a lot of that release was based off of contributions. Absolutely amazing. I like to thank all of our contributors to helping us build out Tech is Hiring, the Tech is Hiring website. And what ended up happening is that there was just a couple of things that needed to be finished, and I decided to take those on. And we also decided to update to Next 13. It was we were using Next 12 at the time, and that update we had to change the way one of our components work, and it was just like a bit of a CSS thing. And I noticed that there were some other issues that had popped up. Now, generally, to be quite honest, in other projects, I would sit there and it's like, oh, there's CSS problems, and you immediately go, God dang it. It's like, I don't want to have to deal with CSS. It's like there's so many people who hate CSS, right? But I didn't feel like that at all. I felt like this, it's a breeze, right? I can just make change. I can make changes, and I can feel very confident in those changes, right? Why is that? Why was that? It's, again, I've been stressing this a lot. It's the relationship between the CSS and the components, right? So the component no longer owns the CSS. The CSS is being applied as if it were an action to the component. And so that allows the CSS, but it makes it so that the changes change primarily that component, and it makes debugging really easy. So if there's a CSS issue, more than likely, and not even more than likely, I cannot even think of a case where the CSS was caused by something else, unless it was maybe like a neighbor, right? But generally, the CSS is where whatever problem is being caused is being caused by the CSS that you apply, that has been applied specifically to that component. So it just gives you so much more confidence in making changes to your component, knowing that like you're not going to blow another component up. Even if there is an issue, it's either the component that you've changed that is causing an issue, and it's or the neighboring components. You know, there's also, I do want to point out that it also kind of makes the, I don't want to say it makes the code tidy, but it just makes it easier. You put all your presentation logic in one area. We'll get to that in a minute. We put all your presentation logic in one area. It just makes it so much easier to deal with, you know, working with your presentation logic. And yeah, and then you can make and it's really easy to make refactors. And you know, I'm gonna stop singing this and praise the functional CSS. I really like it. So separating presentation logic and business logic. So self-explanatory. Keep your presentation logic and your business logic separate. Now, I want to explain what presentation and business logic is. Presentation logic is pretty much anything that displays something on the screen. So in the web, the way we think about is what this is HTML, CSS. Obviously, you can use JavaScript to put HTML and CSS on to add markup, but it's just whatever logic that you're using to display something on screen. Business logic is generally to the way we think about it is to how we think about it's enforced like a business case, but it's just like the best way you can think about it is how to, like, if you need to do like fetch data or something like that, if you need to do something functional, not necessarily like you want to manipulate data, you want to get data, you know, like the reason why it's called business logic is it usually is attached to a business use, a use case. So say for instance, you know, you want to get all rows, I guess this is a database example, get all rows from orders, you know, like that's what would be that code that does that would be considered business logic. So here, so we have an example here of co-locating business logic and presentation logic. This is React. We have a component here that's a button, and when you click on the button, you go and you fetch a cat image from the cat API, because I like cats. Leave me alone. I clearly like cats. Anyways, I need to stop making this. Again, you see me giggling a lot through this. We get the cat image, and for whatever reason, I've decided that we're going to replace test button with the cat image, right? So here we have the fetch data function literally in the component. And there are a couple of problems with this. Problem one, the way I tend to think about it is, if you want to test this, it becomes fairly difficult, right? So you go and for you to test this, you would have to render the component. Then you have to have your test runner click on this button, and then you have two options, right? You can either mock the fetch data and check if it's been called, or you can wait for the fetch data to get, you know, your image, and get fetch data to get your image, and then check if things have changed. And that's not even actually a really good thing that you should be doing anyway. But like, also, if you need to change things, this is a very contrived example, but you can imagine if you have a large enough component or elaborate enough component, you have multiple business you have a lot of like business cases in that component if you're co-locating all of this code, and it just becomes hard to manage, right? So yeah, that's pretty much it. Like, you have it, testing becomes really difficult. It can be like, once the component gets really large, it can be really difficult to manage both the presentation and business logic, you know. And then also I want to point out that you have this tendency of coupling presentation logic and business logic. So if you write them both together, you have this tendency of I'm going to write my business logic specifically for this component that I'm using. And so obviously it becomes really hard that, say, for instance, if you need to use that business logic elsewhere, you either go write it over again, or it just becomes a little bit difficult to pull out. It just becomes a bit of a pain. So I just want to point, so we have separated presentation logic and business logic, and I do want to point out that the code has not functionally changed. In fact, the only thing that has really changed effectively is this line. This line has been added, fetch data. But now we can test the presentation logic separately. You probably wouldn't test this, but say, for instance, the thought that I immediately have is you have like a drop down, and you want to make sure that the drop down renders properly, so you can test for that specifically. Otherwise you don't have to worry about testing. Well, I don't want to say, if you have other ideas of testing, that's fine. But now, say for instance, this fetch data, you probably wouldn't test this specific thing, but say this is actually significantly more elaborate. You can focus on testing this separately, right? And I've been talking about tests all this time. You build a much more robust test suite. This is actually technically from a Node application, but it's the same kind of thought process. You have your code split out so that it's doing, you just have it split out to do specific things. And you can just build a very robust test suite, and you can pull more value from your test suite. You can be a lot more confident about the things that you're testing, right? And you can also organize your business logic. So this is technically from the Tech is Hiring, the Tech is Hiring open source project. As you can see, we have everything kind of sorted out in its own folder. Components is pretty much where all the presentation logic is. Images is obviously where images are. Interfaces is where all the interfaces are. This is TypeScript. And then I try to put as much of my business logic as I can into a lib folder. And here I want to highlight is I have an API layer, and then everything that involves the API layer is here. So this is technically layered architecture. And the idea for layered architecture is that you co-locate all the code that does one type of functionality into its own layer. It's very easy to do. There are other ways of organizing your business logic, or just your code base in general. I don't want to get too much into them because that can and has been a whole talk on its own. Whole books have been written on this, but I just want to point out that this is a benefit that you get. You get to put your thing, all your code in what you consider logical ways, and it just allows you to interface with the code a little bit better, right? Right. So I would like to start talking about a little bit of tooling that supports this architecture, right? I primarily want to talk about Storybook, right? So Storybook is a way of documenting your design system. And here's an example of this. This is literally BBC's design system. They have a Storybook up. If you're interested, you can literally go to this link. It's a little bit small, but you can go to this link and you can just literally see their Storybook instance that they have live. What you can do is you can see the components that they have in their design system, and you can interact with them, with these things called knobs. And you notice that there's various ways you can interact with them. Icon, play button, yeah. But the primary way, and a good example is clicking the disabled button, and that will show you a disabled version of the link, which I believe is a grayed out version of this link, right? So you document all the behavior of your component, and it also serves as a visual smoke test. So you don't necessarily have to spin up the entire project. You spin up Storybook, and you can just go and look at the component, and it's like, okay, this is doing exactly what I intend for it to do. And I've heard of this as a controversial take. I don't know why, but you can also leverage Storybook as a way as an isolated development environment, right? So in terms of an isolated development environment, I'm pretty sure everybody who's done front end long enough has had like a large enough application where you have multiple screens and you have like a flow through those screens. It's not particularly easy to get to some point in your application, and you have to do some work on screen 3, right? So what you do is you go to your router and you start banging it with a stick, and then you come up with some convoluted way so that you can just immediately go through to screen 3, or you do the other tiring thing and you just click through to screen 3 through all the things that you need to do, and then you start working on your code, right? And I guarantee you, if you've changed your router, you've probably at some point done all the work that you needed to do, and it's like, I'm done. And then, you completely forget to change your router back, and it's just like, okay, now I just messed up the whole thing, you know? Whereas with Storybook, again, as you can leverage Storybook, where it's like you just have an environment there where you can build your components in isolation away from your project. And it helps, again, we talked about, or not again, but we talked about atomic design and component-driven design, the idea of building your components first. This just kind of gives you a blank canvas to build your components first. Right, and I just want to point this out. I just want to give a quick shout out to Kadisha Kerr, who from GitHub. She wrote a blog piece on GitHub Code Spaces, which is something that I've been leveraging recently, and just kind of being able to set up a particular workflow through that using Code Spaces, and then. Sorry. So I should I should say this again. This is the Tech is Hiring open source project, and she has this setup where you install all your dependencies. You pretty much everything's ready to go, but you also spin up an instance of Storybook, and it opens a tab to the Storybook instance, so you can just immediately get to work. And I just thought it was absolutely amazing. I wanted to point this out. Thank you so much, Kadisha. So I'm pretty sure everybody here has heard of TypeScript. It's a superset of JavaScript, sits on top of it, and its primary job is adding static typing to JavaScript. One moment. So the thing that we want to leverage from TypeScript is, of course, the enforcing the shape of the data that goes into the components that we use, right? So it's like, I'm pretty sure you've kind of pulled in a component and you've expected that you can pass something into it, and then it turns out that it just doesn't use it at all, and things blow up, you're all sad-faced, right? So TypeScript kind of helps with that by, saying, okay, these are the things that you can pass into the component, right? And you don't have to these are the things you can pass into the component. But a really big deal is also that TypeScript technically acts as the first line of documentation for your components, right? So you import a component, you go to leverage it, you can get IntelliSense on the component. It will tell you what props it may use. Obviously, well, this is more from a React standpoint, but it will tell you what it needs, all the things that are necessary, things that may not that are available but are not necessary. It just acts as a really good way of being able to kind of interface with these components, right? And also, using the component incorrectly, you get a yellow squiggly or red squiggly based on your TS config, which is pretty much tells TypeScript how to run, and it makes the development experience so much easier or better, right? I do want to point out a bit of an alternative. I'm pretty sure, well, I'm not pretty sure, but if you've been on a Twitterverse, you've heard like people talk, saying that they're not really interested in using TypeScript. Primarily, to be fair, these are like people who are doing who are using npm. But I do want to kind of point out an alternative. If you're not as excited to use TypeScript, leverage Storybook more, right? So Storybook is an excellent way of documenting your components. excellent way of showing like how your components work, what you can do, what you can do with them. It's like you can definitely lean more on that as an alternative. Right. So to recap, we have component-driven design, which is pretty much viewing your pages as a collection of components, and you focus primarily on building those components first. Atomic design, which gives us a battle-tested way of a battle-tested way of thinking of the relationships between our components. Functional atomic CSS, which is pretty much flipping the ownership, flipping how you do CSS, where CSS is now like actions as opposed to being owned by a component, and separating presentation logic and business logic. And then we just talked about Storybook, documenting your component, your design system, and good old TypeScript. Right. So what do these things enable you to do that may be a little bit beyond the scope of this talk? I just want to point out some interesting things that you can leverage with this type of stuff. So beyond this, you have things like the idea of having an organizational component library. This is This is GitHub's design system primer, and this is the React components for that. And you can literally just npm install this. Is at the bottom. Probably should have highlighted that, but you can literally npm install it. I'm pretty sure GitHub uses this for all of their projects. And the idea here is that if you have a very structured way of how you do these components, you don't necessarily have to just have them be for one project, or you just have to repeat the code. It's actually, I have a good example of this, or good example. I worked on a project where we had to build out a mobile app drawer. For whatever reason, we just couldn't, pull one from the web. And the person who was building out the app drawer knew that they had a friend who had built it out previously, and so he went to them, and he just sent in the code, and then he just had to adapt it to our project, right? Like, that's silly. Like, if you have something like this, you can host your npm library, either in your organization's network, or even through npm, and you can just pull this and install it and leverage it, and you have components ready to go, right? And specifically for whichever organization that you're working for, say for instance, you have a particular use case, you have a component that only does a particular thing. You can now you can add a little bit more coupling there. Was like, okay, I want the component to do this specific thing, and you just have all of your developers have access to this now, right? And not only that, is like, somebody builds a new component, they can just add it to this library, and now the entire organization has access to this, right? Let me go away. Yeah, and then we have this idea of server-driven UI. I've heard of this mostly from Netflix, and the idea here is that your front end, your client side application is just a collection of components, and the server literally tells you what component to use and how to structure that component, as well as passing the data through it. And the use case that I first heard of this is, you have a mobile application, you send it to the App Store, and then you want to make a particular change to how the application is, right? And so, do you want to publish it again to the App Store? Maybe not. So what you do is you build your client side as a blank slate, and the server as the thing you control, that can send responses to this application. The application will build the UI on the fly based on those responses. And the only way you can really do that is to have this structure, to have these, like, have the structure in your front end, so that your server knows what components are available, knows what components are available and what it can do to those components. It becomes infinitely harder when you're building things very haphazardly. So thanks so much for attending my talk. I really appreciate you taking the time to listen. I do want to point out that the tools and techniques I brought this up a lot, but the tools and techniques that I spoke about are being used for the Tech is Hiring open source project, and you can go to the repo at github.com/techishiring/techishiring-website. And we have a storybook that's live. You can go to stories.techishiring.com and check that out, just to kind of see an example of this stuff in action. I do want to give special thanks to Rizal and Ramon, who runs a Twitch stream for people to come and practice their talks. I was on that Twitch stream twice. This is technically my first talk. I should have pointed that out. This is my first official talk, and they really gave me the space to kind of practice this. And I just wanted to, thank them for just encouraging me to do this. I do want to point out. I want to give a special shout out to Khadisha Kerr, who again works at GitHub, wrote the blog post for the GitHub code spaces, and was just so gracious enough to add a contribution, and an awesome contribution to the open source project. Thank you so much, Khadisha. And I also want to give a shout out to Jeff Beck. He works at Mozilla, and to be honest, the talk wouldn't be the way it is without his input. And I just want to give him a special shout out. Thank you so much, Jeff. So where you can find me, I'm Chad_R_Stewart on Twitter, X, Algebra. I'm going to call it Algebra from now on. Find X, right? I'm not even, So, you can find me on Twitter. Anyways, you can find me on Twitter there. I'm also on LinkedIn, linkedin.com/ just /in/ChadRStewart. Also, Tech is Hiring is on both LinkedIn and Twitter. You can find us on Twitter on Tech is Hiring, @Tech is Hiring, and on LinkedIn, linkedin.com/company/Tech is Hiring. But again, thank you so very much for attending my talk. I really hope you learned something. Thank you so much.
Thanks, Chad. That was great. There was so much good information in that talk that, I want to go back and review it again, because I think, many of us don't necessarily put enough thought in advance. And when we're developing these things, developers just like I'm just going to start coding and I'll get it, and then it works. And, and it's just like you end up getting stuck in many senses later on. Trying to go back and fix this is not necessarily an easy task, right? So first of all, I do want to get to questions from the audience. We did have one, but if you have additional questions, we have a few minutes here for you to ask your questions. I've got some, but I do want to get to the audience questions first. So Dominica asks, can you use CSS nesting in this approach, or does it beat the idea of atomic design?
I don't think you can use CSS nesting. I've had this conversation before. I'm going to be quite honest with you. Like, my interface with functional CSS has really been Tailwind. I did want to point out, so you can build your own functional suite of CSS, but how do I put this? I would refrain from it, just from my understanding of functionals, of the ideas of functional CSS. Like, ultimately, you can do whatever. Like, the way they try to present it is they try to have it like you have one or a small amount of styles per action, per class. If you're interested, you can build that class however, but I would keep it to a single action, or I wouldn't leverage nesting personally. But again, my main interface is with Tailwind, So you can try it out, but I don't know if I don't think it would be the best idea.
Okay. So I'm curious. You talked a lot about in the atomic design part about particles and atoms and so on, right? Like how is there any kind of rules that you use to determine what makes something a different, like an atom versus a particle versus I can't remember all the different terms, but
Mhm.
a molecule. Like, is there, or is it more like up to the developer to kind of determine what fits where?
So the way I think about it, so Brad Frost, was very specific about, like, you have a collection of atoms. You have, like, an atom is fundamental; it doesn't rely on anything. Then a molecule is a collection of atoms, and an organism is a collection of molecules and atoms. And so what I do is I kind of think about that, and then my own experience will kind of determine that what those relationships look like, right? So the way you think about atoms is like you want your atoms to. I should point out that, so, like, as you go up in that kind of hierarchy, is the use case becomes significantly more specific, right? So, like, organisms will tend to be, like, more specific. Atoms will be much more general, right? So you think of atoms as your general things, buttons, text, stuff like that. Icons, things like that, things that you can use everywhere, right? Molecules are more like, say, I'm looking at literally the UI, like your input box where, it's input and then it's a button, right? So I guess I go with kind of like what the Brad Frost example, and then I just use my experience to determine, how I feel, what I feel kind of fits that idea. I'm not sure if that's helping, if that answers your
Oh,
question.
that does help. I think what clarified it to me was this idea that it gets more specific as it goes up the chain,
Yes.
because the um, when you get to, what is it, particles, where was atoms, then molecules,
Yeah. Atoms,
then
then molecules, then organisms, then templates.
organisms.
That's when, yeah.
Right, organism. So when it gets to the organisms part, like that is probably more specific to a particular um, implementation on a page, right? Like, as opposed to everything else is like more reusable.
Yes, yeah,
Um,
yeah. So pretty much, yeah, that's the best way to think about it. The lower you are in the chain is the more reusable the thing is, right? As
mhm.
you go up, as you get to templates and pages, obviously, they're very they even though they like, templates can be reusable, they tend to have like a particular use case, right? So
Mhm.
as they go up, the use case becomes more narrowed.
That makes sense. That makes sense.
Yeah.
And so, and as far as, I've never used Storybook, is it so? Storybook is it something like you have to pay for, or is it?
Oh no, it's open source, so you can just literally npm install, and you get an well, it's npm, it's npx, whatever. Like, you can definitely install it into your project. You don't have to do anything elaborate. Well, you have to set it up, but yeah, and it's just you. I'm. Could you elaborate a little more, like what? Like, yeah. Sorry, I'm a little.
That's okay. So it's open source. There's no cost over. They do have like I guess there is an enterprisey thing that they,
Yeah,
or is
yeah,
this
yeah.
okay? But I like for personal, for these kinds of projects, like you could do it without necessarily utilizing the full
Right. Yeah.
paid
So
thing.
I just literally have like something set up. I have like a GitHub action that's set up so that, whenever I update whenever I do a pull request, it will just update the instance of Storybook and just send it off to Vercel, to be live. But yeah, I didn't have to pay for anything. It's just open source.